What we're going to do today is we're going to look at the number 1. And if I multiply something by the number 1, I get the same thing back. And we've already used this as a way of changing the way things look. If I was adding fractions, I need to get a common denominator. So I multiply by the number 1. 2 over 2 is 1 to change the denominator. And so that gives me 2/4 and 5/4. That's the answer. And what happened here was this changed how this looked, but it didn't change the value. And that's the power of number 1. We're going to do this in physical quantities. And the thing we're going to start with is length, but anything we can measure, we can treat mathematically. So for example, if I have a ruler and the ruler has a total length of 1 foot, and so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches. This is something in reality. And so when I go to measure something, I write down 5 inches. I'm saying 5 times this thing in reality that's an inch. This is mathematical. We're doing a multiplication. Now if I go 3 feet 2 inches, I'm implying that I have 3 times something that's a foot plus 2 times something that is an inch. And so these things are like variables for something in reality. Now something in reality is held in a measuring device, in a ruler. And what this helps us with is what we mathematically need to do to change from one unit to another. So, for example, notice in a ruler here, I had 1 foot is equal to 12 inches. This is a truth. And sometimes you'll see you get 3 lines here saying 1 foot is defined as 12 inches. And so something about this thing in reality and this thing in reality makes this true. So whatever I'm multiplying by here, there's a mathematical relationship. And we call this the unit analysis. Your book will say dimensional analysis. There's a little more to dimensional analysis than just the unit, but we're going to focus on the unit part. So, I could look at, let's see, I'm 5 foot 10 inches. Now what I said up above, that's 5 feet, 5 times feet, plus 10 times inches. Well, how many inches am I? I would need to change this, just like changing a common denominator, to inches. But I have the tool here. What I need to do is I need to multiply by something that has inches upstairs and feet downstairs. Well, if I come over here, let me divide both sides by 1 foot. So let me do this here. And come down a step here. So I'm going to take my definition, 1 foot is 12 inches. I want to divide both sides by 1 foot. Now anything divided by itself, including feet, is the number 1. And so I get the number 1 is equal to 12 inches times 1 foot, or 12 inches divided by 1 foot. Now, this is the number 1. So I can come over here and I can multiply 5 feet by the number 1. It won't change it. Because remember, anything times the number 1 is itself. So I'll multiply by 12 inches over 1 foot plus 10 inches. The feet cancel, because like a fraction, feet over feet. And so I have 5 times 12, or 60 inches, plus 10 inches, or 70 inches altogether. And these statements of conversion create these fractions. Now notice I could have gone the other way. I could divide by 12 inches and I get 1 foot over 12 inches is equal to 1. So these fractions are flippable. What I need to do is put on downstairs the thing I want to get rid of, and upstairs the thing I want to keep. And this is how we build conversion factors for converting. Now, in the English system, we have which is this system here, we have a couple of common, we have 12 inches equals 1 foot, 3 feet equals 1 yard, and was it 5,280 feet is 1 mile. Those are common in the English system. Outside of the English system, we have the metric system, which uses 1 meter as its base. Now in the metric system, they put prefixes to multiply this by powers of 10, like scientific notation. So a kilometer is 1 times 10 to the 3rd meters, because a kilometer is 10 to the 3rd. And then there's a centimeter, which is 1 times 10 to the negative 2 meters. There's a millimeter, which is 1 times 10 to the negative 3. And so these prefixes are multipliers of power of 10. And what we want to do is we want to collect some powers of 10. And so commonly we have K for 10 to the 3rd, and that's kilo. And then we have hecto for 10 hecto. Hecta or hecto? It's hecto. I always get my O's and A's messed up in Greek, which is 10 to the 2nd, or multiplying by 100. Then we get deca, which is 10 to the 1st. And then we have the base unit itself, which is 10 to the 0. So you don't change anything with the base. And then we start going down. We have centi, which is 10 to the negative 2. Milli, which is 10 to the negative 3. And then we tend to go by 3s. Just like when we add commas in numbers, we want by powers of 3. And so milli, micro. Now because there's 2 m's here, we're going to use the Greek m, which is called mu, 10 to the negative 6th. And then nano, 10 to the negative 9th. Right, so like a nanometer is the size of light waves are in nanometers. Micrometers, that's the size of bacteria. And millimeters, right, that's like how much your nails grow, how much nails grow. And then centimeters, we start, we see millimeters and centimeters on our rulers. Kilometers is running distance, equivalent. And so these are units that tend to be used in science because the base 10 makes for easy conversions on them. And so what we can do, is we can look at a system where I know 1 inch is defined as 2.54 centimeters. So, if I want to talk about I will go, we run 5 kilometers. So how far is 5 kilometers in miles? Now, I can look up kilometers equals miles and do a conversion, but I'm going to do this the messy way. I'm going to go by the definition here and build it all the way across. So what I know is 1 inch equals 2.54 centimeters. So I'm going to need metric here. So I'm going to make a train of things. I'm going to have 5 kilometers is equal to, well, kilometer, okay, is 10 to the third meters. Right? 1 kilometer, because this was 10 to the third, is 10 to the third meters. So I can write this conversion factor here. And so now I'm in meters. Now, 100, I'll keep doing it this way, 10 to the negative 2, 10 to the negative 2 meters is equal to 1 centimeter, right? Because 1 centimeter is 10 to the negative 2 meters. What I've done is I've lined up, the kilometers are going to cancel the kilometers. The meters will cancel the meters, and I'm left with centimeters. And now I can use this. I can turn this into my fraction. So I'm going to have 1 inch is equal to 2.54 centimeters. And I've used this to switch from metric to the English system. Now I need 12 inches in 1 foot, 5,280 feet in 1 mile. And I've lined up my units so that everything cancels but the unit I need. And I put all my math here. So I have 10 to the third divided by 10 to negative 2, so that's 5 times 10 to the 5th, using my exponent rules, divided by 2.54 times 12 times 5,280. And so what I want to do here is I'm going to grab my calculator and type this out here. So let me see if I can get my calculator up here. Where did I hide my calculator? It's not showing up on the screen, so I'm going to type the number out on the side here. My apologies. So 5 times 10 to the 5th. I'm just telling you what I'm typing as I go through, and I'm trying to get it to show on the screen here. 10 to the 5th divided by, I will put parentheses, 2.54 times 12 times 5280 parentheses, and I get 3.106, or approximately 3.11 mile. And if you've ever run a 5K, that's it. It's 3.11 is the distance people use. And so this is how we do dimensional analysis to convert. We make sure our units cancel out, and we turn these into nice fractions. In fact, that's the linking fraction right here between English units, inches, And the metric system is the definition that 1 inch is 2.54 centimeters. And then we line up the conversion factors. Now, you can find that what is it? It's approximately 1 mile is like 1.6 kilometers. You can use that as a conversion factor. That's not. No, I will have to look it up. And that's the problem, is I've gotten so used to using this conversion factor and work my way through to build these. You do chemistry, you do dosage calculations in medicine. You'll be grabbing a couple of these fractions that do your converting. And so whenever you have some equation, you can turn it into a conversion factor. That's what we also call these, conversion factors. This is the key to dosage calculations in nursing, is that you string together the things that you need to calculate. And we usually do it in a way that things cancel out rather quickly, and we try to focus on powers of 10 so it's easy to calculate in our heads. We will look at more than length in the next video.